Hello everyone, welcome to the tutorial series of Python language quantitative trading practice. Today we will learn about the condition structure, which is the if statement we have used for many times before. We do a demonstration in our strategy library to learn the use of conditional structures deeply. Here we write if close more than open. There are some functions in the local code block of this conditional branch that cannot be called. For example, some drawing functions bar color, fill, hline, plot, and so on. We can find them all in the API function. In the API document of FMZ Python language Python script documentation. Here. We can find them in the contents. Let's go back to our strategy page. These will report errors on the trading view if written in the if condition, which is not as restrictive on FMZ, but it is recommended to follow the specifications on trading view. For example, we write strategy here. Strategy test. And let it draw on the main chart. Then we use the plot function to draw, passing in the built-in variable close. Here. Name it as close. Again, we draw the chart in the else branch. Here. We pass in the built-in variable open here and name it as open. This will not report an error on FMZ. We can click backtest here and to see. We can see that the chart has been drawn out here, but there are places like this one. The value of open is NA here. That is, it doesn't execute, it jumps right over where there is a value, jumps to the next place where there is a value, and then connects to a line. Although this does not report an error on FMZ, It is not recommended. In the global scope, let's write a more complex example. If the if statement has many conditional branches, then how do we design it? For example, we start by declaring a global variable, line color. And we initialize it to NA here. The if statement can return to a value, as we have mentioned in the previous video course. For example, here we declare a variable n and return to the value with an if statement. If the k-line bar index of bar index more than 10, if bar index more than 10, and bar index less than or equal to 20. Here we use AND to connect them. Oh, it's less than 20. If so, we assign the line color to green. We go on to write the next condition. If there are another branches, we use else if here. If bar index more than 20, and bar index less than or equal to 30. If so, we assign the line color to blue here. Here we change it as blue. We go on to write else if. We can copy it and paste it here and change it. If bar index more than 30 and bar index less than or equal to 40, we assign the line color to black. Change it to black. If all of these conditions are not met here, then we write else if else if bar index more than 30, more than 40 here. We assign the line color to black. Oh, the color is the same, so we change this one to orange to distinguish them. If none of the above conditions are met when we design a conditional branch, we process it with an else statement. Assign the line color to red here. We use the plot function to draw the built-in variable close. Name it as close here. With the color assigned to n, that is the value returned by the if statement. And if the condition holds, the color of n is green. Then we set line width to 5 here. And let it draw on the main chart. Then we use the plot chart function to draw the bar index. The first parameter we pass in true. Then we let it draw above the K line for our observation. And then we name it as bar index. Convert the character char with the string-to-string function. Then set the location above the bar. And set the color as red. Finally, we let it draw on the main chart. Then we click Backtest. We can see that all the contents are drawn on the chart and bar index starts from 0 here. That is, the index of the first k-line in the chart is 0, and then increment 2, 3, 4, 5, and so on. In the code page, here we set from 0 to 10. We did not make a conditional judgment on it. Then it was attributed to the else condition. And then the line color was assigned to red. Here, red. And return to the if condition statement at the return value. When the chart is drawn with the variable n, it is drawn in red here. From 10 to 20 here, we can see the line is green. The first condition in our code is met. So the line is green here. That is, the bar index more than 10 and less than or equal to 20. Followed by blue, orange, and black. We can see that after 40, if it's greater than 40, the line followed are all black. If there is no structure executed in the if statement, and we still need to return a value to a variable. What kind of value will it return? Let's write a simple code to demonstrate it. We declare a variable x here. Assign it with an if condition. We write close more than open. If. Don't forget if. If close more than open. In this condition, we assign it with close. We use the plot function to print x, name it as x. Here we click backtest. And we can see that when there is no value, the closing price of the k-line is returned. Here, no value. We can see that when there is no value, the closing price of the k-line is returned. And if it's negative, NA is returned. Here, NA. That is, no chart is drawn. Let's go back to the code page. From the chart we drawn out, we know that x is assigned to null value when close less than open. So if returns to NA, if there is no condition to execute. In addition, there is another branch structure named switch statement. There are several key points. The first point is that switch statements, like if statements, it can return values. Here we write x equals to switch. The switch statement in a Python language does not require a break. When it triggers the execution of a branch, the color conditions that followed it are not executed, so the break keyword is not needed. Each branch of switch can write a local code block, and the last of the local code block is a return value. We can write a string, variable expression, or function description in the expression in the judge position of switch structure. Switch is also allows specifying a default return value. If all the conditions in the switch are not matched, then the default value is returned as specified. In the Python language, the switch statement can be written in two forms. Let's start with an example of a switch with an expression, where we declare a function variable. We use the input string from the input function series. Set the string EMA as the default value. And name it as indicator name. And the next parameter, tooltip. We set it as select the name of the indicator function to be used. Here we can use selective input values among the conditions of options. We can write the string EMA, string SMA, string WMA, and string RMA here. Which are all variants of the average indicator. But here it is just a string. And we need to execute different branches in the switch according to this string. We can go back to the backtester page. We can see that our indicator is already shown in the strategy parameter column. It's EMA. Let's continue to write our strategy. We declare another variable first period. Here we use input int to assign it. Input int is to assign an integer because we want to use this parameter as an indicator period, so here it can only be an integer, not a decimal. We write 10 here. Name it as first period parameter. And here we can use selective input values too. We use integers. Options. Equals to 5, 10, 20. Then we declare a variable slow period, use input int to assign it to. And just copy and change it. Here is a slow period. We set the 20 as default here. Title, slow period. And options we set as 20, 25, and 30. Is the moving average we need to calculate based on the closing price or the opening price. Here we declare a variable data. We use the input function. The default variable is set to close here. And name it as data. Tooltip here we set as select the closing price, opening price, highest price, and so on. We set the color variable for the first line. First color equal to set it as red. Then the slow line. We set it as color red too. The switch structure can return not only a single value, but also a tuple value. We return it to the tuple value. Input fast and slow and assign it a value with switch. We judge the condition that switch returns according to the string function. Here. When function is equal to EMA, it executes its local code block, giving the first line a value assignment. We use TAEMA function. Pass in data and the first period. Also the slow line. Modify the global variable first color to red. We use the assignment operator here and modify the slow color to red too. Finally, we return the return value of the conditional branch. If function is SMA, we have to execute the branch code of SMA, which is the same as the EMA above. We can just copy and paste it. We change the O to SMA. And the color we set green here. Then we write RMA. Here we change it RMA. And the color we set as blue here. If there is nothing in the switch condition that matches equal to or more than, then we throw an error at this point. We use runtime error function here. We use the plot function for drawing. We draw fast first. Name it as fast. And add a period of fast period to it. And set the color as fast color. Finally, let it draw on the main chart. Let's proceed to draw slow. Just copy and paste it. Change it to slow here. Name it as slow. As we have said before, we try not to write function calls in condition branches. But here we write function calls because the design is fixed when the parameters are running. The conditional branch is also explicit in the runtime. That is, it ensures that the function is called on each bar and does not change other conditional branches temporarily during runtime, in which case it is possible to write the function in a conditional branch. And we click backtest. We can see that it draws two lines on the chart. One is fast line, the other is slow line. Periods are 10 and 20 respectively, and both of them are red. In the strategy parameter column, we can see that the fast line period is 10, the slow line period parameter is 20 here. Here the indicator name is EMA and we change it to SMA. and click backtest again. We can see that both of the line becomes green here. Then we change the slow line period to 30 here. And change the indicator name to WMA. We can see it reports an error here. No lines was drawn out. Let's go back to our code page. We can see that we didn't write WMA here. So we change it to RMA. Click backtest again. We can see the two lines are blue here, and the slow line period is 30. It is possible to write no compatibility code on FMZ, and it is similar among if conditions. Let's take an example. We write strategy test. And let it draw on the main chart. Then we declare a variable x equals to if close more than open. If so, let it return to close. Else, let it return to string open. Such a code here will not report an error on FMZ, but it will report an error on the trading view because the returned types are inconsistent. Here is close, but here is string open. Let's look at how to design a switch without an expression. It's more simple. Here we declare a variable name it as up. Let it equal to close more than open. That is, we use the expression close more than open to assign to it. Then we declare a variable, name it as down. Let it equal to close less than open. That is, up here is a positive line and down is a negative line. Then we declare a variable by using var. We let it initialize only once, use the up of count. Assign 0 to it. Then we write down of count, assign 0 to 82. Then we write message color. Here we use the switch branch to assign it a value, and here we design it as a switch without an expression. That is, we let it determine directly. If up is true, we let it execute a branch. Here we let up of count add 1 to itself. Then we let it return to green. And if down is true, we let it execute another branch, just the same as above. Change it to down. And we set the color red here. Then we use plot chart function to draw it if up is true. If up is true, we name it as up. And for the character chart, we draw the number of times for positive line. Use the string-to-string function. Set the location above the bar. And we set the color as message color here. Let it draw on the main chart. Then we draw down, use the plot chart function, just the same as above. Name it as down. set the location below the bar. And we click Backtest. We can see that on the chart, all the K-line bars marked as 0. Let's go back to our code page to check it. Oh, we can see here the sign is equal, not minus. We change them and click Backtest again to see it. Then we can see on the chart, all the K-line bars are marked with numbers. When the K-line bar is positive, the marker is shown above, and when it's negative, the marker is shown below the K-line bar. Switch local code block plays the role of assigning values to the color according to the true or false of up. And accumulating the variables they count. So we can see the values on the chart, cumulative changes visually. The use of this switch statement is a branch to determine the truth or falsity of a variable directly without using an expression. In general, this condition following the switch statement must be mutually exclusive, that is, there can be only one condition with a true value at the same time, and the corresponding branch code will be executed at this time according to this condition. If both conditions are true, it will only execute the first condition, that is true, but without executing the second condition, that is true. So this is what we need to be aware of when using switch structure without expressions. In addition, try not to write function calls in branch structures, because they may change during running and jump to another branch, which may cause some problems, and the function may not be called on some bars. So we need to make sure that function calls are called on every bar. So that's all for today's lesson. If you think our video tutorials useful, don't forget to like, follow, and repost. Your support is our greatest motivation. Thank you all and see you next video.